Hey, okay. Great to see you all, and great to be here. It's kind of funny about keynotes because essentially people are always asking for something new or controversial or interesting. And then that basically goes and forces the people who deliver keynotes to go and think of what's new and interesting and controversial, right? And I think what I decided with this one is just to basically go and start to deal with some of the issues that we have around AI, right? And it's very interesting to notice that there really hasn't been all that much in the conference space about this. People talk about this. I'm sure everybody here has basically done a bit of work with the various different AI tools that are available to you right now. You probably have very different opinions about whether they're good or bad or whatever. So I decided to go and just consolidate my experience a little bit with this and a couple of different thoughts about where these things might be going, what they're good for today and what they're not so good for today. So really just basically talk about the state of tooling, okay? And to give you this caveat, okay, that essentially this is the point of view from 19 October 2023. So anybody who's basically looking at a recording of this, talk, months from now is probably going to be laughing because it's like, oh no, that's what they thought back then, right? But anyway, let's go and kind of carry forward a little bit and talk about these things. So the three main things I'm going to go and talk about in the context of this is really the three different interaction styles that people have with AI these days. I'm not going to get into the names of particular tools and stuff like that, but they should be kind of obvious when we go through different examples. But the three different interaction modes are completion mode, comment mode, and chat mode, right? And completion mode is typically if you're working in an IDE and you're starting to type something and then suddenly it goes and says, hey, I think I know what you're doing, and it goes and gives you a completion for that, and you get to select that completion or not based upon what you're doing, right? Comment mode quite often happens in IDEs where you basically start typing in a comment and then it generates some kind of code based upon the comment that you've basically placed in your IDE. And chat mode is something which is kind of like, if you're working with ChatGPT or basically IDE tools that have like a little chat window, you were able to go and ask it to do things for you, give you summaries of things or generate particular methods and things like that for you. So these are the three main interaction styles that we see today. And we're going to talk about different things that kind of come up in the context of each of these things. So I want to start all this out by going and dealing with the hard problem, okay? And you might say, well, gee, what is the hard problem in all this? And I think the hard problem is really this. It's temperature. Have you heard this terminology before, temperature in conjunction with AI? Okay, so this is a term generally for the amount of randomness that's injected in the process of going and actually sort of decoding something within a GPT model. So the idea is that essentially it's kind of like, for every token that you have, basically there's a vector of tokens that could possibly be successors to that token. And the probability of, or the weight for those particular tokens, and those things are kind of sorted. And the notion is that essentially it's like you could go ahead and say, let's go ahead and sort of select the next most probable token after the current one. But what we do with GPT is we basically inject a degree of randomness to this, right? So it isn't always the next most likely token, it's some random fluctuation around the next most likely token. And what's interesting about this is that essentially when we're working with code, one of the things that we really hope for more than anything else is the ability to go and actually deterministically produce a solution that is correct, right? So it's kind of funny, with this notion of temperature, which can be varied in many tools, it might seem that we want temperature to be 0, right? Meaning that we're always going to go and select the next token, which is of the highest probability that would be necessary for us to go and, produce what we need. But the thing is, when we basically make the temperature 0, we end up with this strange thing here, right? So here's a little bit of example text done by Stephen Wolfram, and he wrote this very short book a while back, What is ChatGPT and how does it work? Or why does it work? And he basically sort of like, through a simulation showed what it would be like to go and actually decode something from a GPT model and in English, and basically go and always generate based upon the next most probable token. And you'll notice by looking at this text that there's a lot of repetition here, right? And it seems like this is just what happens. Things get very uncreative when you're always going and choosing the next most probable token without injecting any randomness at all. So the interesting thing with this, though, is that it seems like we want to have the temperature to be really low for determinism. But then when we do this, we're kind of sacrificing the creativity or the things that basically our models are, theoretically give us. So it's interesting to notice that essentially the same thing that gives us creativity also gives us hallucinations in the context of AI, right? So we can have a very low temperature, but it doesn't do us very much good. If we raise the temperature, we basically have things which are more creative, but they can be so creative that they're nonsense sometimes. So how do we actually start to deal with this in the context of software development? You know, it's kind of funny because, you know, essentially this thing of temperature gives us creativity, also gives us hallucinations. But is it the case that essentially, you know, all of the things that generate usefulness give us hallucinations as well? And I don't think that's really necessarily the case, okay? So we're gonna have to go and talk about this thing of temperature and what this really means for the things that we do, which are hopefully more deterministic with our systems, right? We want to write code that's correct. We want to perform refactorings that are correct as well. So yeah, we have a bit of work to do with this. The next problem in all of this is really the thing that is, I noticed very interesting, you know, when I first started working with AI tools, and that's that the way that we interact with them as programmers is very frustrating. I don't know if you've actually noticed this or not, right? But I know that for somebody who's had years and decades of experience as a programmer, one of the things that you get very, very used to doing is basically specifying things very, very precisely. It's true. That's what we do when we program. We have to specify exactly what it is that we want, and the compiler will complain at us if anything is like slightly off in any way. So I found myself when prompting for code generation tasks doing things like this. Please change the use of vector to array list on the third line of retrieve mail method on the server class, right? Is that overly specific? It is, right? Quite often what happens when you're working with an AI tool is that basically it's carrying context with it based upon your prior interactions. And you can just take little shorthand things and do them. You can just sort of like, you can do things like not be very polite, for instance. We don't need the please there at all, right? But we can just sort of like, I like to use the word please because it's more polite, I guess. And if we are nice to AI, maybe it'll be nice to us. Who knows, right? But it's strictly optional with this, right? And so do we have to be this precise with everything that we use in our prompts? And the thing is, not necessarily. And it's kind of frustrating in a sense because I want to be more precise. I want to go and have it do something specific for me. But I'm always lulled into this thing of like, I can be more vague and still get results. So it's kind of hard to go and find that sweet spot as a programmer when you're using tools like this. And I find that a little bit frustrating. So, you know, there's this thing. We don't have to be terribly precise and we'll still get something useful. But we do have to go through that review step to understand whether the thing it's generating for us really is useful for us because of the temperature thing that we mentioned a bit earlier. And, you know, this lack of precision extends to all sorts of things. You know, it's like, I misspelled array list here, right? Does it matter? No, it's not going to care. It knows what you're talking about, right? You can basically get away with some of the most crazy, short little things and actually generate things from them. And one thing I've seen people do over and over again with their prompting is almost create little mini languages in a way, sort of like saying, when I say this, I mean this in their initial prompts. And you can sort of like use a very like constrained abbreviated language to go and get the kind of things that you want, which is interesting in and of itself, okay? But the thing that I think is very frustrating for us in a sense is that we can be lax. And lax, this word means relaxed. It's kind of like we don't have to be precise. We can be vague and ambiguous in what we say. But the thing is, AIs can be lax with us again too. It's going to go and generate things which are not exactly what we need sometimes, but often things that are kind of close and we have to do the evaluation to see if they really are good for us. So when things are lax, we can't really relax, right? It pushes more work onto us as developers. So I think the thing that's interesting for this is that it really kind of leads us to a new communication problem when we're using AI tools. And it's kind of funny because in a way it is a bit of an old problem. We basically, you know, we need to go and communicate with this thing, and essentially GPT tools are basically built to mimic pretty much the way that humans actually reason in a sense. You know, when you think about how a model is trained, it's all about generating impressions, basically go and cause it to have different weights within the model, which basically sort of allow easier pattern matching. If you think about DALL-E, for instance, for image generation, the reason why some of the things it produces are almost like dreamlike in a sense is because it's going and generating something which is kind of close to what you're thinking about, but maybe a little bit different in a sense. So it's funny because this kind of vagueness is really part of human communication. And what we're doing is we're reproducing this within the tools that we have. which is okay, except when you really want determinism. So the model typically for us as developers has been this. You're a human, you talk to a computer, we pretend to be a computer to talk to the computer. We use a very precise language like Java, for instance, or C, or Scala, and we basically are unambiguous in what we write because we want deterministic results from the output of the program that we're writing, right? But now what we're doing is we're sort of saying, okay, human is going to talk to a pseudo-human, right? This thing which kind of acts a bit like a human, and then it goes and sort of like generates the things which go onto the computer, right? So it's a bit frustrating that way, right? Because the thing is, it's kind of like the tools are not human in a sense. They are prone to error, and we are really in that spot where what we have to do is we have to basically deal with another bit of a debugging chore. That's not just the gap between us and the precision that we need to go and run something, but now we're going and introducing a bit of vagueness, and then basically getting a bit of vagueness back in communication with the tools that we have. So one of the things that I mentioned earlier is that there's different modes of interaction with AI. And one of the most common ones that I see people using is really this, where it just does completion for you, right? So you type in like private double factorial, and then basically it just goes and offers a completion to you and says, hey, this looks like it's kind of what you want to do. And it goes and gives you the code, right? You've all tried this before with AI tools? Yeah, kind of useful. But the thing about it, though, in a way, is that we've been here before, haven't we? I mean, in essence, this is the same as going and Googling for, example code or using Stack Overflow and just finding a little piece of code that you're going to copy and mutate into what you need it to be. And I think the same thing happens, with this that happens with all those other tools. There's no guarantee of correctness for the things that you find, right? And I've seen a number of videos which go and discuss things that are just very salient and kind of subtle, something that looks superficially like it's going to work for you. And then you discover there's something slightly off, and just because of the randomness that's been injected in the process. So it's tempting to go and just sort of say complete, 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 and have something, but you'll spend an awful lot more time debugging than you really anticipate quite often using tools like this. So it's nice, but it's also nice in much the same way as Stack Overflow was nice, or Googling for an example piece of code was nice. We have the responsibility to go and actually make sure things really are correct when we're doing our work. So is this a benefit or not? As much as Stack Overflow is a benefit, I think, in some sense. So the next thing really is chat mode, right? And there are various different ways of going and dealing with this. Some IDEs are basically giving you chat mode windows as well. You can ask for certain things and ask it to go and modify things within the code base that you happen to be working in. But one of the things I find very useful for this is just explaining things, right? So, we'll quite often go into like even just GPT-4, right? And go and say, what does this code do, : and then just drop the code in and see what happens, right? And, quite often you get a decent answer. So, with this, it's kind of like, okay, I dropped in this code, and I can't even show you the end of this. It's a couple hundred lines of code in Java, like some very ancient Java. And it basically gave me a nice description, okay? So it tells me this code represents a simple email broadcasting server in Java using the Java Mail API. And it breaks down step by step, all the different things that it does. And, it's kind of nice because you can ask further questions. You can say, what are the 5 most important responsibilities of this server class? And I find in working with AI that I get a lot more utility out of this than the code generation. If I basically have some piece of code I don't understand, it seems like GPT understands cohesion pretty well and coupling pretty well. And it's able to go and basically infer from names and also the structure of pieces of the system, what are the core responsibilities of some particular piece that you have. And that can be very useful, particularly just to go and try to make sense of what's going on within an application. And I just find myself doing this over and over again. And I just find it, again, very useful. So with this class that I kind of dropped in there and got a little bit of a description of, I started looking at things and I realized that one of these responsibilities, number 2, reading the recipient list, I could see in the code where that responsibility was. And it looks kind of like this, right? So this is all inline code. And I thought, well, this is kind of nice. Can I actually extract this into a method? And so, of course, I asked for that. And then it's kind of like, okay, well, it goes and says certainly, and it gives you all this verbose answer, and then it goes and generates something for you. And so it gives me a read recipient list method, and it has the call in the place where it was, made. And this one actually looks pretty decent as extraction goes. But the thing I'm finding, though, is I'm getting much better results from, say, ChatGPT than a lot of the tools that are kind of baked into IDEs. And so there's this temptation to go and just sort of drop code in there and go and get results. And then you have to copy these things out and back into the IDE. It's really a, kind of awkward workflow at this time. But yeah, it's a bit of a problem. The other thing I've kind of noticed with this as well is that there is this interesting problem that I call the session state problem. And it is this thing where sometimes you sort of are getting, it suggests a refactoring for you. And then you basically do something different. And then when you ask it for the next step, it goes and assumes that basically you've done the refactoring it suggested to you. And that's a bit of a problem because what is going on is it seems like, it's through the session that you have interacting with the tool, it's going and giving you its idea of what the next thing should be, but it's not refreshing based upon the current state of the system. Or it's, it's kind of like, I think that what must be going on with this is that in your interaction, it's going and building like an intermediate state, but it doesn't know what intermediate state to go and actually discard when you actually do something different than what was planned or what was offered to you as a plan by the tool. And that's really kind of frustrating, and I don't know how soon that'll be kind of fixed in some of these tools, but it's one of those things that's kind of odd, particularly because, we're not always going to go and take the suggestions sometimes, right? Quite often we'll see a different or better way of doing something than what's suggested, or something which is further in line with the goals that we have for what we're actually going to be doing. The next problem is something that I'm sure you all have kind of thought about or basically encountered, and it's called the context window problem. Either that, sometimes it's just called the token limit problem, for instance. So the way that GPT works is that essentially you have this concept of attention where it's basically going and sort of like figuring out, based upon all the context you've given it, what is the next token as you're going to be marching through things. And essentially because of the way this process is, formulated, it's roughly like an n-squared problem, and people are doing a lot of work to go and basically make it much more linear in a sense, and then correspondingly allow you to go and have many, many more tokens like in memory or in context at once that you can work in. But it's definitely not the case that you can go and take an entire code base and say, hey, here's 5 million lines of code. I want you to understand this so I can tell you to do things and what should be done next. It can't really go and handle that much at once. And, we might look at this as being a bit of a problem, but I think given the hallucination problem, it's kind of interesting because if we are forced to work in smaller contexts, that's good because we actually do have to do the checking to make sure that what's produced for us is, good enough for us, right? So I find myself going and asking questions of smaller areas of code and asking for generation of smaller areas of code rather than saying, here's a giant code base and let's go and do something that's, major across the entire code base. We're simply not there yet, and thank goodness, because we don't really have decent ways of checking those things yet for things. So another thing that people have been doing an awful lot with AI is essentially this. Anybody know what this is? It's a boilerplate, okay? We never think of what a boilerplate looks like, do we? Oh no, actually, yeah, okay. So it's just kind of like this weird thing. And, it's kind of like the thing that we do quite often, like give me the shell of like a Chrome plugin so I can actually go and start to modify it and do some work. And, in fairness, we've had stuff like this for ages where basically people give you a scaffolding or something like that and you have like a basis for an application, then you just sort of inject the code that you need to go and grow it into the application that you need to go and produce, right? So the interesting thing about this is that quite often you can build this scaffolding very quickly. Give me a particular thing that does this. But the thing that's kind of odd with this is kind of like understanding and managing the boundaries. So I kind of look at things this way, right? It's kind of like, you have the code that you write, and we might say that's the code that's on the right here. And then what we have on the left is basically the boilerplate that we generated through a prompt, for instance, right? And that's fine. The only thing which gets kind of problematic is when you start to mix these things. When you start to go and use AI to go and actually refactor both the thing that's been generated as well as the thing that you've supplied yourself. It's kind of like having like an overlap in a sense where you start to lose the boundary, and I think that's tough because quite often the boilerplate that we generate is not something you're going to test very easily. It's something which is kind of like meant to be a surrounding piece of the stuff that you're working on. And it's really nice to go and maintain that kind of separation. The logic that you're introducing yourself should be something which has some separation from what's generated for you. And this is part of an age-old problem we've had in programming, which is kind of like, you have a framework and then basically you have code that you call from the framework. If you don't have separation, it's hard to test the code that you're introducing yourself, and it's hard to go and understand it separately. And if something's generated and you didn't produce it, it's nice to go and have that degree of separation there. And if we don't have that separation, things can kind of fall apart. So this is, I think, a common thing that happens with this is that if we start to go and mix what's being generated with what we are actually producing by hand, we get into this confusion sometimes, and it makes it kind of hard to modify things going forward. Another thing which I think is kind of problematic, that's kind of coming to the fore sometimes with this, is something that, cognitive scientists refer to as availability bias. Has anybody ever heard of this before? It's a really simple concept. It's kind of like, suppose you walk in through that door over there. Are you going to come down this way, or are you going to walk all the way across in the back and come down that way? Chances are you're going to walk down this way if you came in through that door because it's the easiest decision you can make. I want to go down into a seating area. I'll just start going down immediately rather than walking all the way over there and going down in that particular direction. So you can guess that most of the people walking in this door are going to come down through this staircase rather than that one, right? And this basically deals with all sorts of things in life, right? Your best friends are people you work with sometimes, or basically people that live in your hometown, or people that are available to you in certain social media that you've come to basically favor. So it's all these things where decisions that we make are often biased towards the things that we have available to us. How does that basically affect us with AI? Well, it's kind of interesting. It's like rather than going and starting from scratch and building things, we just basically say, hey, generate this piece, generate this piece, generate this piece, and we just kind of assume that that's good enough. And that can be good enough in many cases. But the thing is that to the degree that we actually go ahead and sort of follow that easy path with things, we're also going and sort of sacrificing some design decisions that we could make, right? We could make a design decision to go and say, well, I know that we would generate something like this, but I really want something which is far more like this, and it's going to be better for my moving forward with the stuff that I'm writing over time. And because it's easy, we just basically find ourselves getting into this kind of narrow path in some of the things that we do. And for things that are not critical, that can be great. Okay, for things that are a little bit more critical, we might want to go and basically sort of express things, much more deterministically, so to speak. So we've talked about a bunch of problems, and I don't want anybody to think that I'm kind of like down on AI and I think it's terrible. I think it's got a lot of promise, but I just do want to go and outline things that I basically think are problematic and could possibly be worked upon, right? I think one of the more interesting things that I've been thinking about and working on a bit recently is the notion of how you actually go ahead and sort of have some measure of correctness of the things that you're generating when you're using AI, right? So I wrote this up a while back, and it's a technique I call prompt hoisting, okay, which is a strange piece of terminology, but let's go ahead and sort of like talk about this in comparison to its alternative. If you're going and working with an AI tool and trying to go and sort of work and have it generate code for you, quite often you go through steps like this. So you prompt the tool to generate a method for you, or you start to type it and have the tool complete it, right? And then you review the generated code because it might not be what you need, right? And if it's not, you can make some modifications for you. You can also then prompt the tool to write some tests for you. And then you can review the generated tests because they might not check the exact behavior that you intended either, right? Does this seem like a good idea at all? I got so frustrated when I saw people say, oh, just have it generate tests for you because nobody likes to write tests, right? But the thing is, how do you know the tests are correct, right? You're really in trouble with this sort of thing, okay? So, I think that the thing that's really kind of nice in a way is to go and sort of, well, the bad thing, first off, is to notice that this has 2 review steps, right? Okay, you have to review the generated code, we have to review the tests that are generated for us. But a better workflow for us is something which is kind of akin to test-driven development, right? Write a prompt which is executable as a test, use the prompt to ask the tool to generate code that passes it, run the prompt as a test. Just run it in the IDE as a test to go and see that the code that was generated actually does go and satisfy that test, right? And you can review the code that passes the test to see if it passes in a way which advances your design. If it doesn't, you can modify it, and you've got the test, of course, to go and basically see, whether that code that's generated actually does the work, right? So this is a nice workflow. And the thing is, I've tried doing this, but I think we're not quite there with the tooling yet, unfortunately. And a lot of it has to do with this thing that I mentioned earlier, the session state problem, right? occasionally it's kind of like you do something a little bit different and then you ask it to do things and it's a little bit off in the direction that it wants to carry things. And as well, it's kind of unclear what is the prompt really when you're doing this. And I think the reason why it's unclear is because you have the prompt that you basically put yourself, but there's also all the context of the interaction you had in that session before, which is basically going and giving it other constraints when you're working on things. So what I've typically done with this is write a test, basically go and say, in the prompt I go and I say, write code that satisfies this test. And then basically it does it. And then basically I go and I'll basically start mentioning, it's like, okay, write code that satisfies all the tests in this suite, for instance. And you find that you have to go and you have to try that many times sometimes to go and actually get the test to go and pass against those things, because it starts to go and lose, I guess, enough attention to go and actually satisfy all those tests at once. So it does start to fall apart at some point in time. But it tends to be kind of useful when you have a small number of tests to constrain the solution that you're actually going and generating. But I think it's an interesting thing, because it kind of like points in a direction of where we might want to go with things. It's a shame I didn't record this, but I saw something on Hacker News about a month or so ago where somebody sort of set this up as a loop. And it's kind of like, okay, give it the test, and we'll basically go ahead and keep running things over and over again until we get code that satisfies the test. And I thought that's kind of interesting. But again, you probably want a human in the loop to go and actually see that the code that's generated is intelligible in some sense and allows you to go and sort of maintain it further. So I think we're not going to be replaced by code generation for a while at this point in time. The thing about this, though, is that I think that this particular thing is a little bit more general than what we do in code, and it's something to think about in terms of like potential other products that we might have on in the industry. I just generally call this approach generate from constraints. And I'm giving you a small little example here, just as a, but I'm sure you can kind of like extrapolate this to many other types of manufacturing and stuff like that. So essentially you might say, okay, well, here's everything in my kitchen, all the ingredients that I have, and here's all the appliances I can use to go and work with those ingredients. Generate a recipe that will use these ingredients, right? And chances are AI is going to do a decent job of this, but you can basically set it up so that you have like an external checker, and the checker basically goes and takes all the things that you listed in your prompt, and it goes and uses those to go and verify that the recipe that you get back only mentions those ingredients and those appliances. And if it really adds anything more, then it'll just tell you that you can't do that with the ingredients you have on hand, right? So this seems like a way of going and actually sort of like getting the hallucination problem under control to some degree. And I'm surprised that this hasn't become a more common approach. But it seems like when we need that kind of determinism because of the hallucination problem, having some way of going and actually constraining the solution that we generate and giving us some indication whether it doesn't satisfy our criteria seems like a decent thing to do. Because as I mentioned earlier, it seems like the hallucination problem is built in to some degree because of temperature in the process. And I don't know where we will be in a couple of months or a couple of years with regard to that, whether we'll get far more determinism and not care as much with this. But I guess we'll have to see where that goes in the industry. So the next thing I want to talk about is reasoning limits, okay? And this is something I was really concerned about early on when a lot of this technology was first kind of put out in the public. What are the constraints on what GPT can do for us based upon the way it was trained? And so I thought of a couple of different things that I might use to go and test this. The thing I was concerned about is that it seems like when they trained all these models, what they did is they just started scraping the internet and getting all the text that was possible to get and sort of like building up models based upon tokens, right? Descriptions in text. But what about things that have never been described before? How does it do on those particular things, right? I was talking to a researcher a couple of weeks ago, and he said that, it's interesting that basically you can tell by the way that weights are distributed in a model where you might have more hallucinations because there's just less connection in those areas. There's less for a particular token, less options to go and get to the next token. And they're using that to go and sort of understand where hallucination might occur and then how to go and actually sort of deal with that in training. But I was worried in particular about the fact that many things that we have as part of our reasoning don't even seem textual to me, right? So a thing I did, about a year ago when this stuff first came out was I asked this question of GPT. How is the zip function in functional programming like a matrix transpose? Okay? And this is just a weird insight that I had, a couple of years ago, maybe 5 years ago at least. I was working on a little application, and I kind of noticed that When you have a zip of 2 lists, you're basically going and saying we have 2 rows, right? And then pairwise is kind of like going and sort of like taking that and flipping it. So a zip is almost like a transpose, but it's a transpose of 2 rows with all the columns, right? And so it's really the same operation structurally in a sense. And at first, ChatGPT was saying to me, there's no relationship. Matrices are used in linear algebra, and zip is used in functional programming. Zip basically uses pairs against 2 lists, and basically transpose, does just, working against, a full matrix. And that was the answer for a period of time. But just checking the other day again, it's kind of like now it's much better. It'll basically tell me more about what zip does. And then basically it gets down to the very end, and it goes and, points out what the resemblance happens to be, that these have a common structure, right? That zip and transpose have a very common, thing. But I love how at the very end here it goes and says, the resemblance is a neat observation rather than a fundamental mathematical or conceptual link, right? It's kind of a funny thing because I kind of like discovered this in programming, and just when I wanted to have like zip, and then there's zip 3 and zip 4, zips of like multiple lists and stuff like that. And I thought, wow, it's kind of like I can just use a transpose in the language rather than saying zip 5 or zip 6, right? And yeah, that was kind of an interesting thing that I actually reached for transpose instead of zip because my problem kind of called for it. So that was very useful for me to go and see that structural relationship. And here's GPT telling me that it's an accident, it's not important, and there's no conceptual link between these things. No way, okay? I think that the truth is a little bit more subtle than that. It just hasn't caught up with us yet. So yeah, other examples of structural reasoning, it's like, remember asking it, how are Markov chains in the GPT decoding process similar? I don't know how many of you are familiar with Markov chains. It's kind of like this process where basically what you do is for every token, I guess, that you have a list of the possible next tokens. And basically you select one based upon a random function and stuff like this. And it seems very similar structurally to what GPT decoding does, based on the description I gave you a little bit earlier in this talk. And in the very beginning, it would say, no, these, GPT decoding is very separate from Markov chains. They have nothing really in common. But now I'm getting a much more reasoned, explanation of things. And it basically specified a lot of the differences, specified some of the similarities as well, right? And I think this is really kind of an interesting thing to go and notice, is that essentially, even by going and just working straight with text in its training, it is able to start to discern things which are very structural, or almost visual in a sense for me when I think about code and systems. I'll sort of like focus in on one particular thing that is structural in a sense, but it also goes and gives you the possibility for different use. And I think that's something that you can probably see with the transpose zip example earlier. But I like to think about things this way, that a lot of reasoning is not necessarily verbal, for instance. It can be structural in a sense. And then sometimes when we're being creative, it's kind of like in taking something that has a particular structure, finding something that's similar in structure and just going and using the wrong thing sometimes. And this is a thing that artists do all the time. They'll basically sort of like, oh, this light looks like it's good for using on a stage, but I can pick it up and make it into a lightsaber. It's like that was not intended to be a play lightsaber from Star Wars, but you could use it that way. It's just not how everybody has used it before, right? You see a different use for something. So I think that this kind of structural reasoning is kind of core to our creativity. And for a long while, I thought that GPT wasn't going to start to be able to approach this, but somehow it's doing better with that. So I think, it's another case where things are just advancing very quickly in this area. So, kind of like summing up a lot of the things that we've talked about here, the main thing that it seems right now is that because of temperature and because we need determinism, we really do need to have like a human in the loop when we're doing things, right? And I think you'll notice that people are not saying this very much explicitly, but it is something which is kind of like being noticed, for instance. When I see people trying to use AI for different things, I'm seeing things like, oh, okay, give me stories based upon this description, right? Or help me estimate based upon different things that I've been doing. And so it's giving you textual output, which you can kind of review and say, well, either I like this or I don't like this. Either I like the user stories that were generated by the AI or I modify them slightly. But it's under your control. It's not a straight line to the compiler where you just sort of say, hey, take this and run it and we'll just assume it's correct, right? We have to apply our reasoning to go and actually verify that what's being produced is useful to us. And it doesn't seem like there's anything which can kind of like substitute for that right now. In essence, we really are moving towards more of a generate and test paradigm for things. It's kind of like, ask it for something, it generates it, but then we have the full responsibility of verifying that that particular thing really is going to satisfy the problem. And from a legal perspective, that's where we're going to be also, right? You're generating things, and essentially, if they're generated wrong, your company is just as liable as it would be, if a programmer had done it. That's just the way liability works in law generally. So it seems like what we're able to do with AI now is really a lot of this: ideation, explanation, and options, right? Have it help you basically go and decide what to do next. Have it explain to you what it sees, for instance, and basically use it to explore options. So as I was pointing out a bit earlier, it's kind of like, that thing of like asking what the most important responsibilities are for a class. I love doing this sort of thing because quite often, it'll match my perception of things or give me insight into things that I hadn't really seen previously. So it's almost like talking to somebody else and saying, hey, explain this to me. And of course, when you're talking to another person, you never take what another person is saying as like the complete truth. It's just that person's opinion. And AI gives you a different opinion with these things. And it does seem to be the case that AI is very good at going and actually understanding cohesion and coupling, and that's nice for us. Other things too, like planning refactorings, okay? Give me a multi-step refactoring strategy for parse radio broadcast in the following code. And I dropped in a bunch of code there, and it goes and gives me, different things I might choose as possible extraction points. And that's nice. It gives you ideas about how you might want to separate responsibilities in something. And then your regular refactoring tools that you have for yourself are just nice to be able to go and help you with that. And I could go deep down into this and just sort of like point out, all the different things that you might want to go and think about when you're doing things. And there's a lot of creativity you can basically apply with prompting to go and actually sort of give it enough background about your intentions to go and actually give it you better ideas about things to do. But again, I'm finding that a lot of this stuff is really not in the completion space at all. It's really in the space where we're actually able to chat with the tool and actually ask it to do things for us. So that's kind of what I see right now here, today, okay? And I just want to go and share that with you all and sort of get you thinking a bit more about this and where you might think these tools might be going. In a way, I feel kind of like with this talk, I may have given you some stuff that you didn't quite know, but I know that a lot of you have been playing around with this and probably have arrived at similar conclusions with this. There's not just the issue of kind of like having things that are slightly wrong, but we're also in this situation now where, worldwide, we're trying to go and basically understand the copyright implications of things generated with large language models. So I think there's been an awful lot of people not really using it because they're kind of concerned about liability in many cases. And that's fine, and I think it's just being cautious is a very useful thing with tooling like this. A thing that I find interesting, though, is to think about, where this might possibly go. And I started thinking about, just wild possibilities for the future. Could we actually set things up so that we can read a gargantuan code base and essentially get to the point where we can ask it to go and generate code based upon what we need now, some subset of the functionality that is in that main code base, right? Or some variation on that functionality, and have it generate those things and compile it for us and give us an executable directly. And just see how possible that is. At that point, doesn't the repository become actually, no, the model itself becomes the repository, right? Imagine that future where we don't even have source code much anymore. We've read a lot of source code and we ask the AI to go and generate something for us. It generates all the way down to the executable, and we just are able to use it and be happy with that. Can you imagine that? I don't think we're anywhere near that, okay, but it's an interesting thing to go and consider. And I think the reason why I think it's possible at some point is because it seems like historically we've always had that thing of like generating new languages and having them output a previous language, and then that gets compiled down to the executable, right? And it's kind of like we can wonder about whether the source code that we have right now is actually going to be an intermediate language that could actually be removed at some point, and we can just generate directly to the executable from our intentions. And I think, it's funny because I think there's a lot of life-critical things and risk avoidant things that you might want to do. You would never want to take that out or take that particular thing. But there's also a lot of a lot of development that happens that's not all that critical, and people don't mind having a couple of errors as long as it can make them money quickly and it doesn't bother people too much, right? So that's an interesting thing to consider, is that when you're doing something simple like a social media thing, and if you get it wrong, you're not going to annoy people too much. You can have things generated and it will be fine, But that's not the same as like handling millions or billions of euros or dollars and having lots of people upset if you make a mistake, right? So it's the low criticality uses that'll probably go and sort of be the leading edge of where AI is used for things. I think the other thing that's interesting too is to think about that from the legal point of view. It's kind of like, what if there's a bug, right? Who is liable for this and what's going to go and happen? And I think it's interesting as well to go and notice that we've already dealt with that problem to some degree. I think with medical imaging, it's kind of like a powerful thing as well. Like people are using AI to go and actually sort of, do scans or basically sort of analyze scans of like brain tissue and all these other things and give you kind of like a prognosis or a diagnosis of some medical condition. Of course, the human's going to look at that and validate the results, but the thing is, it's like in cases where you're using neural networks, traditional neural networks, there's no way pointing to a particular line of code and saying that's what produced this particular answer. But still, these systems exist and they're being used, and somehow people are handling the liability things in nice ways. So yeah, we're probably going to basically have to continue working with very deterministic systems for a period of time, ones that are actually visible in the sense that we can actually see the source code that's produced by them. But we'll also probably move in a direction where we don't have that, and we might be happy for many uses. So I guess we'll have to see where that goes. So anyway, lots of thoughts. And it feels like I'm kind of like done a little bit early, but I guess I can open up for questions if anybody has anything. Yeah, please. I don't have one.
Could you open an app in the browser?
Yeah.
So,
Oops.
yeah, wall.
Sorry?
W-A. Oh, sorry.
No problem. Yeah, I should have set that up. Sorry. Oh, good, yeah.
It should appear here. A room number 9.
Okay.
And yeah, I can show that.
Great. Okay. So I guess we can start.
We can show that.
Oh, okay. Sounds good. I thought I had that. Okay, are you able to present from this? I don't know quite what I would do to present from this. Fair enough. Good idea. Okay. Yeah, forgive me. It's like 1 a.m. where I come from, right? Half asleep. 2 a.m. All right. So do you think the advance of AI will change the skills a good software engineer needs to have? Yeah, I think so. I think we're still going to be in this state where we need to go and actually review things to understand whether they're working correctly or not. So that means that we do have to have in-depth understanding of the things that are generated for us or the modifications that have been made by an AI system. So yeah, I think there is that thing where we still need to understand things well enough to be able to go and sort of like assess things. The people that don't really understand things well enough, they're going to probably get themselves in a lot of trouble very quickly, and that's just an unfortunate thing. I think the other thing, though, that's interesting is that this is also going to probably take us into an area that we've been moving in for a period of time now, which is basically developers not just as people who create solutions based upon business people's ideas, for instance, but are also able to go and very rapidly sort of try things out in terms of different business ideas, right? I think a lot of the things that we do as software design right now, the same concepts of cohesion, for instance, and stuff like that, will be applied to like product feature set, right? We'll be thinking about which features actually will interact best with other features and how best to generate code that actually goes and sort of works within that framework. So I imagine that we're probably going to see a bit more overlap with like UX and basically people who are going and doing product design that will be basically doing the same kinds of things together, Next one. Okay, so you've been talking about session state problem. Have you found a reliable way to refresh GPT context with your own tweaks so that it works on the current state? Not yet. I haven't been able to find that sort of thing. Okay. Okay, so I haven't really been able to find anything to deal with session state right now. But the thing that's funny about this is that I can't be the only person who's noticed this sort of thing, right? And it seems like it should be something that tool developers would be looking at very carefully in order to go and understand how we can maintain current session state, even when you take a direction which is different than what the AI is suggesting to you. So yeah, I haven't seen anything yet with that. But I imagine people are working on that. Okay. So next question is like, hey, Michael, okay? You show us old Java class and ChatGPT knows what the code does. It understands it. But there were quite some method comments. What if no comments? With no comments, it tends to do pretty well. I think it's able to go and infer very well based upon, very like naming and also structure. And that's, a very useful thing. It's one thing I haven't done is basically like take a class, strip out all the comments, but also change all the variables to ridiculous things. But I'd imagine that in many cases, GPT would do just fine with some of those things. Almost like, code that happens to be kind of like, encrypted in a sense, where the method names are given like X, Y, Z or something like that. The thing that's interesting about this is that quite often in our minds, we separate the semantic level, which is the naming, from the actual structural level, like what are the lines of code and how do they interact with each other, what's the structure of the method and the class and stuff like that. And essentially because you're training with both of those things together, and both of those things are being assessed at the same time, it's kind of like it is able to go and sort of like, at a deep level, see connections between structure and semantics. And even without the semantic naming, you might be able to go and find some things out. I remember an early experiment I did with this where I did do a little bit of that, like renaming things to go and see if it would still give me a decent explanation of what's going on. And for simple things like a Fibonacci program and stuff like that, very easy to do. It seems like for things where there isn't much of a history of that particular structure being used to solve a particular problem, it kind of like fumbles a little bit with that sort of thing. I realize I'm not talking about the comments here, I'm talking about the names of the methods, but I think it's the same kind of thing. In general, I've been dropping a lot of code into it that doesn't have comments, and it seems to do okay based upon the naming. Okay, another question. What about brutal refactoring release date? Okay, I've been thinking about a couple of other things in book space, so I haven't really got a name or a particular date for brutal refactoring, which is listed up on Amazon as my next book, and it's been that way for years. But I don't think that's actually going to happen. It'll probably be something different I'm working on now. Okay, you were talking about the idea of AI eating code base of product and spitting tweaks on demand. We are lazy by design. Isn't that an idea for the beginning of Skynet, right? It's funny. We can go, rather deep into this thing of like, the AI apocalypse and stuff along those lines. But I think, I don't know. I go back and forth between being scared of that and then also kind of recognizing that, it's kind of like there's a long way to go before you actually sort of like have things going and generating things for you that are impactful in the world in dangerous ways. So I don't know, I go back and forth with that. But I think, this thing of going and generating things by design or generating things, product tweaks and stuff like that, we'll probably see an awful lot of that in the entertainment space first, where people are kind of like, okay, this is what a person's gameplay is like. This is the kind of thing that we think will be useful to them, or they may enjoy, so they go and start modifying things based upon, the history of interactions with you. So yeah, I'm sure we'll see a lot more of that sort of thing. But it's an interesting thing to go from that to things like buying things and all these other things where, I think we're going to we'll be very good at basically going and sort of like figuring out where we cede control to AI and where we don't. Okay, ChatGPT is a very expensive model in terms of computation resources. Do you see in the near future a good enough and cheaper open source AI model? And it looks like there's a lot of things out now, Llamas and all these other things. There's an interesting thing that came out a couple of years ago, which is like I think like a leaked Google memo talking about whether they should really compete in the AI space because once models are leaked, people are tweaking the models that basically are leaked and able to move faster in research than some of the bigger players like Facebook and Google, right? And that's kind of interesting to go and consider, is that essentially because these things, even if they're not open source, they are leakable, and people are able to go and basically apply different optimizations to them, that we're going to basically start being in a competitive space where we're going to find, much smaller models to go and solve the problems that we care about, I think, over time. But that's going to be in competition with like the large players, like OpenAI, for instance, who are putting a lot of resources into going and giving us so much capability that we prefer those models than over the ones that are optimized for particular tasks. And it's going to be like a back and forth between those things. So yeah, I think that's just where things go right now. The next question is, what are the leading AI tools for developers? ChatGPT, Copilot from GitHub are well known. Anything else? Nothing else I've really played with in the code space, because I wanted to play with the ones that are actually seem like they're most advanced. And I haven't really seen anything which is really kind of like giving us the same level of output as those things. Let's see, what do you think about the possibility that future software developers will not even be able to review code because they won't even know how to code independently? Yeah, I don't know. It's an interesting thought. I'll tell you a story, okay, a very interesting story from a long time ago. I visited a team working in C++, and I was trying to teach them some modern development techniques, modern for the time. And it was interesting because they were working on this giant graphics-based application, and I decided to show them test-driven development. And I discovered that when I was giving them an exercise, none of these C++ programmers knew how to write a class. And it was kind of funny. Why wouldn't they know how to write a class? But the thing is, they had a tool in the system that optimized the development process by going and actually generating methods based on your description, empty methods you would fill your code into. And it would generate the class behind it and stuff like this. And all developers had to do was basically write the code inside of a generated method, and they were done. And so an entire room of people I was training didn't know how to write a C++ class, right? Kind of scary in a sense, right? I think that's a danger quite often with tooling, is that you can basically become so dependent upon it that you can't actually do the things that you care about. But to be fair, we've been doing this for ages, right? Very few people in this room could probably drop down into assembly language and make a good go of it, right? We always hope that the higher level abstractions that we introduce are sufficient enough that we don't have to drop down into the lower level all that much. And I don't know quite where that's going to go given the temperature problem with AI, whether we'll basically have a deterministic enough interaction with a computer that we don't have to actually sort of like drop down into a lower level. But I guess it's probably coming for some class of problems. Do you think that learning particular programming languages will matter in the future when AI can generate the code from concepts to any language? I think we might start going and finding different programming languages that we basically work on in collaboration with AI. There's an interesting thing in which I don't know if it's gone very far since I looked at it last, but there's somebody did as an experiment something they call pseudo-lang, and it's S-U-D-O, lang, right, if that's all one word. And what it was somebody going to ChatGPT and saying, I want to generate something which is going to help me write programs. What kind of features should it have? And of course, ChatGPT says, it should have these features. And in the process of going and interacting with ChatGPT, you arrived at like a bit of a pseudo syntax you could use for specifying algorithms well enough for it to generate code from simple descriptions. And it's interesting because there was nothing special about this. It was just an interaction between a developer and ChatGPT talking about or arriving at a common language for going and actually expressing computation well enough to do things. So I think we probably will see an even larger explosion of languages, but they might be in many cases private languages that you as a developer produce in cooperation with your AI in order to get things done. And the degree to which these are shared across many different people or AI, don't know how far that's going to go these days. I think to the degree that we're actually able to go and make these languages so tailored to us that we feel only comfortable with those things, we might not have common languages. This is very much like having your own Emacs or Vim setup, where basically it's so special that you can't work on somebody else's machine. It's like you have to work on your machine because you have these things, right? So the same thing might happen, for some people within the AI space. In the context of the recent development of generative models, would you recommend that your child become a programmer? I don't know. It's an interesting space right now. The industry is going through a lot of change, and particularly in the U.S., we're seeing a lot of redundancy, and basically people leaving the industry. But I think that there's an interesting thing with this, though, that essentially there's so much of the economy that's tied to the generation of features and systems that I think there's always going to be a space for that kind of thing. And I'm always reminded of a story that back in the U.S., back in the 1800s, someone was appointed by the president to become the director of the US Patent Office. And he declined because he basically said, everything that's useful has been invented already. Why would we need a patent office? And this is in the 1800s. But I think the thing is constantly true, that we can satisfy our needs with software, but our wants are always larger than our needs. And because our wants are always larger than our needs, and software is going to be a medium to basically express these things, I think there's always going to be a need for programmers. I think the other thing which is kind of fascinating is that there's another thing that's true about software development that's almost like, I guess, a different way of expressing entropy, right? It's kind of like we are always going to be able to generate messes faster than we can clean them up, right? So I think we're always going to have a space for going and modifying things that exist and doing things with it, particularly in the cases where AI can't help us because it becomes too complex. Let's see, okay, so the right way of AI generating code is to teach it. Whoops, can you go back to the last one? The previous one? Okay. So the right way of AI generating code is to teach it the test-driven development, red, green, refactor, review. I think so. I think that's a thing that can kind of help, but for me, it's about going and removing a review step, as I mentioned earlier. It's kind of like, how much do you actually have to review when you've produced something? And if we can basically sort of prompt using tests, that we can actually execute, we can have a bound on things. So I think it's some variant of TDD is the thing that we might move towards. Okay, next question. Did you try to check if GPT would come up with the transpose if you asked about operations similar to zip without giving a transpose on the golden plate? No, I haven't tried that. So it'd be an interesting thing to go and consider, whether that would be an interesting thing to go and deal with. Okay, next thing. Do you see risk in overusing AI assistive tech to generate a lot of unmaintainable code and tech debt that will eventually lead to maintenance hell? Well, you're talking like we aren't in maintenance hell already, right? I mean, that's just the way software development has actually been. I think AI is an accelerant of already existing trends, right? It's easy for us to make messes. With AI, it's going to be easier to make even bigger messes. And that's just the way things tend to be in terms of, entropy and in the way that we deal with things. So yeah, I think, complexity is always going to grow because human wants go and exceed human needs. And we're always going to have things that are going to be complicated and have to deal with them, right? In a way, it's a bit of an arms race, I think. And that's just, I think, the way things are. So yeah, it's funny, because like right now in programming, you're probably not doing the things you would do 20 years ago, right? Far more tools, a lot more of what we're doing right now is optimizing, spend on compute services rather than going and like figuring out what the algorithm should be, right? So basically the things that we are called upon to do always change, but I think there's a core of engineering design which is underneath our thinking process around these things that we're always going to need to basically apply, or something we're always going to need to apply going forward with things. So I think that's all the questions. And yeah, thank you very much. Okay.